Are you fine with that?
I don't know if I can put
Morning, guys. We're going to continue on today. Yesterday we talked about solving systems. And we did a lot with graphing yesterday. No graphing today. Towards the end of the lesson yesterday, we talked about substitution. I gave you some really easy substitution problems. And then today we're going to get into some more that are going to be a little bit more difficult to do. And then we'll get into elimination. Okay. As we go forward with like all of these methods, and that's kind of be what we're going to be kind of talking about in chapter 4 is solving different systems and doing different things with them. Then we're going to talk about, when do we use this method versus another method? Why do we have 3 different methods? Each one has kind of its own reason why we might use it, or different times where this method will be better than this method. Graphing has its place, but as we go forward, graphing is probably not going to be our go-to method. Unless they're both in slope-intercept form and I can put it in my calculator. It's probably not going to be the method I choose a lot. A lot of times we're going to use these algebraic methods of substitution and elimination because sometimes we might get answers that are fractions or decimals, and that's going to make a difference as well. Where if I was doing it on a calculator, then I may not be able to get those. So we're going to start with some substitution again, and we talked a little bit about substitution yesterday, so we're going to continue on with it. And what we said yesterday is we want to isolate a variable. We want to get a variable by itself. And it doesn't matter which variable. It could be x and it could be y or whatever variable we have. Typically it'll be x and y. But yesterday the ones that we did, we already had the variable by itself. And that's what made those really, really easy. Today I'm going to give you a couple that the variable is not by itself. So how could we do that? On this first one, but we have to decide which variable we want to get by itself. And we're always going to choose the variable that has no coefficient. And that means it has a number in front, right? So like here, the x has a 3 in front, the 4y, the 2y. The only one that does not have a coefficient is the x on bottom. So that's the one we're going to choose to try to get by itself. So that means I want to get x by itself. What would I have to do to get rid of the 2y? Subtract it. But what we got to be careful of here is we obviously can't combine those two together. So we just have to leave it as x equals 5 minus 2y. Okay. And you could write that a couple of different ways. You can write it as 5 minus 2y. Sometimes people like writing the y in front and do negative 2y plus 5. Either one of those would be fine. But now we have x by itself. And so what we're going to do then is take this x value, and we have to plug it into the equation that we haven't used yet, which would be the top one. So we're going to put 5 minus 2y in place of x. So we have 3 times 5 minus 2y plus 4y equals 11. We're rewriting this equation, but we're putting this in for x. So we got to distribute the 3. and we're going to combine like terms. The two y's are on the same side as one another, so we're going to go negative 6y plus 4y. And then we're going to solve for y from there. And we get y equals 2. But we talked about this yesterday also. When we write our answer here, we are not done yet because all we know is y, but we still got to find x, right? So y equals 2, but now we got to figure out what x is. And you got some options here. I can plug it in to one of the two original equations, but this would probably be the easiest, right? Because x is by itself, and this would probably be the one that we would choose to use if we wanted to. The only thing would be is if I'm not 100% sure that I solved this right, then you'd have to be careful, but this would probably be my go-to because x is by itself. So we're going to go x equals 5 minus 2 times 2. We plug 2 back in for y. 2 times 2 is 4, so 5 minus 4 would be 1. And 1, 2 would be our answer. And that's what we said yesterday, is our answer is going to be an ordered pair a lot. Okay? We talked about the other types of solutions that could happen, okay? But the one point or the one point where they cross is the solution that we're going to get probably more often than anything else. And we're trying to find that ordered pair. Okay, questions on that one? You guys feel pretty good about that one? Okay, let's get another one with substitution. Okay, there's my two equations. Which variable do I want to get by itself? The y. Yep, the first y over here. And there's a couple different ways that you can do that. Okay, and I think there's probably one way easier than the other to do it, and we kind of talked about it a little bit yesterday when we were solving for y. In graphing, you could subtract 4x and then divide by a negative. There's nothing wrong with that. But I could also add y to this side to make it positive, and then add 13 back to this side. And that would probably be our go-to here. So we're going to say 4x plus 13 equals y. Because I'm going to add y to both sides, and then I'm going to add 13 to both sides. So the y and the 13 are really just flip-flopping. For me, I think that's a little bit easier than subtracting 4x and then dividing by a negative. I think there's less mistakes to make in that case. And it doesn't really matter if y is on the left or right when we have an equation. If we have an inequality, that might change things a little bit. But with equations, it's okay. This is what y is equal to. So we're going to take this expression and we're going to put it in for y. We've got to make sure we put it in for the right variable. Y is equal to this expression, so that expression replaces my y. Substitute it in. Okay, and it really is kind of a big deal when we write it out to use parentheses, because if I don't use parentheses here, I'm going to forget to distribute, and that 4, that minus 4, has to be distributed to both parts. And that's another common mistake that's going to happen here. So parentheses are a really, really big deal here. We're going to take this negative 4 right here, and we're going to distribute it to both parts. Combine like terms. And now we have a two-step equation. Add 52 to both sides. And divide by negative 13. Okay, when we make our ordered pair, make sure you put this in the right spot. Okay, this is an x. On the last one, we solved for y first, and so we put it in for the y value. But here, we got to put it in for the x value. So negative 3 is going to go in front, where x would be. Okay, and when I try to find out what y is, I can use the original here, I can use the original here, or you can use this one here. Okay, and out of those three, which one would by far and away probably be the easiest? One of the two originals or the new one? Yeah, probably a new one, right? Because y is by itself. If y is by itself, should be a whole lot easier to solve than either one of those that we started with. Okay, so a lot of times you could go back to the original, but that probably wouldn't be the quickest and easiest way to go here. So we're going to go 4 times negative 3 plus 13 equals y. So that would be negative 12 plus 13, which is 1. And that'd be our answer. Well, yesterday we talked about checking your answer. Okay, could I still check my answer here? No doubt about it, right? And you would want to check it for both if you're truly going to check it. If I take negative 3, 1 and plug it in here. 3 times negative 3 is negative 9. 4 times 1 is 4. Negative 9 minus 4, negative 13. Works, right? If I do it to the first one, 4 times negative 3 is negative 12. Negative 12 minus 1, negative 13. Okay, and there we go. So I know that sometimes we don't always do that because, yeah, it takes more time, right? But on a quiz or a test, I'll keep stressing that why wouldn't we check it just to see if my answer really does work? Shouldn't have to wait for me to grade it because you know the answer works, right? It's always a good feeling. All right, on this one here, x minus 3y equals negative 4. They won't always be written side by side like this, but I'm doing that just so that when we start to solve them, we can go ahead and start solving them. You don't have to rewrite them. Still doing substitution here. If you have more than one variable that doesn't have a coefficient, then you get to choose. But the ones that we've done so far have only had one variable that didn't have a coefficient. In that case, that's this x right here. So to get that x by itself, what are we going to do? Add 3y. So we get x equals negative 4 plus 3y. We're going to take that expression and we're going to plug it in for x over here. Okay, and really, today's just a lot of algebra, guys. I mean, we're just doing a lot of algebra skills that we've done over and over again. We just got to be really careful about using parentheses, positives, and negatives, and distributing, and all that good stuff. So now we distribute again. Okay, and then look what happens. On the left-hand side, we have 15y minus 15y. What happens when we subtract those two?
0.
They're gone. Yeah, they're 0. So my y's have disappeared. And now I got this weird statement that says negative 20 equals negative 6. Not true, right? Not today, anyway. Negative 20 is not going to be equal to negative 6. What about tomorrow, Shane? No? You don't think so? Maybe Friday? Probably not, right? So negative 20 will never equal negative 6. So we can't let that happen, right? And so if I see that happen, if my y's have disappeared, then this would be one of those where we say no solution. Okay. And some people ask me the question like, can we notice that at the beginning? Not really. Okay. It would be really hard to recognize that right from the start, and so there are ways to do it, but I think just going through it and realizing that as you go through is probably the way to go. All right, let's do one more substitution, and then we're going to move on to elimination. Okay, we have only one variable that doesn't have a coefficient. That's the variable we're going to choose to get by itself again. So we're going to add 2y. So we get x equals 6 plus 2y. This is going to go in for x. We're going to distribute. Okay, and this one's very, very similar to what we just did, right? Because as I look at this, what's going to happen is my y's, once again, are going to disappear. But the big difference here is the two sides are equal this time, okay? When is negative 12 going to be equal to negative 12? Ever, always, okay? And so this is one of those where we say infinitely many solutions. Okay. And that is different. Some people write all real numbers here, but that's not necessarily true. Okay. So infinitely many solutions means there's lots of, basically the reason why is because we have this line, and there's lots of points that would be on that line. And I know we're not graphing it here, but there's a lot of points that would be on that line. So there's an infinite number of points because it goes on forever. There's a lot of points that would make that system of equations true, but it's not all real numbers. Okay, so all real numbers and infinitely many solutions are not the same thing. Because here we're talking about our answer being an ordered pair, not an actual number itself, like x equals 2. And so that's why it's a different answer. And so don't get caught up saying all real numbers. You want to say infinitely many solutions. Okay, so that's substitution, just trying to get x or y by itself, and then go through and solve. The third method is elimination. I'm going to give you a really easy elimination one to start off with, and then we'll talk about some ways or types of systems where elimination is probably going to be our go-to, where we don't want to graph, we don't want to do substitution, but we're going to start with a really easy one here, and we're going to say x plus y equals 1, 2x minus y equals 2. Okay, what we are looking for on elimination is we're looking for one of the variables to be opposites. So if I have a positive 2, I need a negative 2. If I have a negative 5, I need a positive 5. So in this case, it would be these two right here, okay? Because we have a positive y and we have a negative y. The x's are not opposites, obviously. This is a 1x, this is a 2x. Those are definitely not opposites of one another. So either my x or my y has to be opposites, and we also never look at this number over here. it has to be a variable. What we're trying to do is we're trying to eliminate one of the two variables, either x or y. And you get to choose which one by looking at what the coefficients are. Because these two are already opposites, then we're ready to rock and roll. All we have to do is add these two equations together. And that's what makes this one really pretty simple, because we're just going to add straight down. 1x and 2x makes 3x. My y's are going to eliminate, because when I add 1y and negative 1y, they make 0. And then 2 plus 1 makes 3. 3 divided by 3 is 1. And we're already at part of our solution. So we know x is 1. The part that's a little bit harder here is we got to plug it back into one of these two originals. In this case, we don't have x or y by itself. So I got to choose either the top or the bottom. Which one would probably be better here? I think the top. I agree. So I'm going to plug 1 back in for x. I'm going to say 1 plus y equals 1. I can subtract 1 from both sides, and I get 0. So 1, 0 is our answer. Okay. Unfortunately, not all elimination will be quite that simple, but I started with a really easy one and just kind of showed you what we're looking for. All right, this next one is really the, prototypical one where elimination is really, really helpful, and I'll show you why. If we look at the three methods that we've talked about so far, graphing was the first one we talked about yesterday. If I ask you to graph this one, it would be really difficult to graph. Okay, not impossible, but I would have to solve it for y, because y is not by itself. I'd have to get my slope and my y-intercept. Solving for y is going to be some work here. Plus, we're going to have some fractions involved. Okay, so there's a lot of things in there that I'm not real excited about doing. Okay, so graphing is probably not a great method. Substitution is the second method that we talked about, and what we said on substitution is we want a variable that's really easy to solve for. We want one that doesn't have a coefficient, and if I look at all four of my variables here, they all have a coefficient, right? And so none of those variables would be super easy to solve for. Doable, we could do it, but not ideal, okay? And so that's why we really have these three methods, is each one has kind of its go-to of this is what I'm looking for to do this method. And you'll have some problems where it'll say solve using whatever method you want. And then you kind of have to decide which of the three methods fits the best for this particular one, and you can do any one you want. We also will have some on the quiz next week where it'll say you have to do graphing, you have to do substitution, you have to do elimination, but I will give you ones that are easily solved by whatever method that is. I'm not going to try to give you like really hard ones for any of the three methods. Like I wouldn't give you one like this for graphing, typically. Okay, so we're going to do elimination on this one, but what we are looking for is one of the variables has to be opposites. Okay, so we have really two options here. I could make these two the same or opposites, or I can make these two the opposites. And so if I was going to make these two opposites, I would multiply the top equation by -2. And so that would make this a -4, it makes this a +4, and then I can add those two together. Here, they're both +3s. Well, I need one to be negative and one to be positive. And it doesn't matter which one's which. We could make this one negative and keep this one positive, or vice versa. So that's the one I'm going to go with right here. Okay? I'm going to make one of these negative, but when I do that, I have to do it to the entire equation. So let's say I do it to the top. I'm going to multiply the entire equation by -1. I can't just multiply the y. I got to do it to the whole equation. So this equation would now be -2x minus 3y equals -9. So we're really just distributing it through. Okay, the bottom equation, we're not doing anything with it, but I'm just going to move it over here underneath the other one. So now they're lined up. once I've made these opposites of one another, now we can do our addition. Right now we can just add these two equations together. My y's are going to disappear. And 6 divided by 2 would be 3. So we get x equals 3. And then we got to find out what y is. And this might be the hardest part of elimination is none of the equations are easily solved for y. So I get to choose between one of the two originals. I got either the top or the bottom here. Neither one are necessarily better than the other. Okay, so you just got to pick one of them. It doesn't matter which one you pick. They're both going to give you the same answer. So let's do the bottom one on this one. 4 times 3 plus 3y equals 15. Subtract 12 from both sides. Divide by 3. And that's our answer. Okay, on this next one, we just have to make a choice, right? And you got several choices here, but I'm looking to either make x's opposite or y's opposite. And you could do either one. Some of you could choose x and the others could choose y, and we're going to arrive at the same answer. Okay, so it doesn't really matter which one I do, but we're trying to make this as simple as possible. So in this case here, if this is 3, what do I want this guy to here to be? -3. Yep, we wanted to make negative. And if this is 6, we want this one to be -6, right? So I could either multiply this one by -3 to make the x's opposite, or I could multiply this one by -2 to make the y's opposite. And you could do either one of those and it would work out just fine. Okay, so which way you guys want to go? You want to multiply by -3 or you want to multiply by -2? -2? Okay, let's multiply by -2. And we're going to do it to the top. And we're doing it to the whole thing. I go ahead and put it in parentheses just so we kind of remember that we got to distribute it. The bottom is going to stay the same. Those are going to disappear. We get x equals 1. Okay, things should start disappearing really quickly here. Put 1 in for x in our ordered pair. Pick one of the two originals. I'm going to use the first one. One plus 3y equals -1. I'm going to subtract 1. Divide by 3. If we get an answer of a fraction, does that mean we've done something wrong? Not really, right? So don't freak out. Okay, I know sometimes we don't love fractions, but it's part of our answer sometimes. And we're going to get fractions. Okay, and that's another reason why we do elimination is because sometimes our answer is going to be a fraction. And I won't be able to just look at like a graph and be able to determine that. Okay, on this next one, most of the time when we do elimination, these equations are going to be written in standard form. This one obviously is not written in standard form. So we want to get it there, right? We want everything to be aligned. We want x's, y's, and then our constant, the number without the variable. And right now that's not the case. So we are going to move the 2y over on the top equation. So I'm going to subtract 2y. From both sides to get us that. I'm going to leave the bottom equation alone for right now. Okay, and this is probably the hardest of the elimination problems, because as I look at it, on the first couple that we did, all I had to do was multiply one number by something, or one equation by something, and I did it all the way across. In this case, these two are not opposites, these two are not opposites, we don't care about the number over there, but does 3 go into 4 evenly? No, okay? So there's not like a nice whole number that I can multiply by to make it equal -4. Same thing with 2 and 3. 2 does not go into 3 evenly without multiplying by a fraction, okay? And we really probably don't want to multiply by a fraction. So what we're going to do instead is we're going to multiply both equations by something, okay? Instead of just one equation, we're going to multiply both. So I got to find something that both 3 and 4 go into, or that 2 and 3 go into. So what's something that 3 and 4 go into? 12. Okay, what about 2 and 3? 6. Okay, so either I'm going to make both of these 12 or both of these 6. Okay, which one do you guys want to do? 12 or 6? 6? Okay, let's do 6. Now, not only are we going to make them 6, but we're going to make them opposites as well. Right now, these are both negative. We don't want to have two negatives. We want one to be positive and one to be negative. So here's what I'm going to do to make that happen. I'm going to multiply this one by -3, and I'm going to multiply this one by 2. And what that's going to do is it's going to make one of them positive and one of them negative. Okay? And I could do this one as a +3 and this one as a -2, so it doesn't really matter which one we go with. As I multiply through now, what should happen is those two should be opposites after I multiply. So we now have -9x plus 6y equals -21. Down here we have 8x minus 6y equals 20. And things start to disappear. And then -1 divided by -1 gives us 1. Okay, so we have all kinds of options here we could plug it into. What I would probably say is plug it back into one of the originals. Because, I mean, you could plug it into one of these, but there's a good chance sometimes I might make a mistake on one of those new equations. So I would go back to the original equation, one or the other, doesn't matter which one. So let's say I do the top one. Three times 1 equals 2y plus 7, because we're going to plug 1 in for x. We're going to subtract 7. And we're going to divide by 2. Write our answer as an ordered pair. Okay. So you're kind of starting to see there is a lot of work involved with these. There's not really any shortcuts. If there are shortcuts, I'd show you shortcuts, but it takes a little bit of work to get through problems like this. All right, I got one last one I'm going to show you here. Okay, once again, right now we don't have any opposites. So I'm either going to make these opposites or these opposites. really doesn't matter which one I do, okay? So let's say I'm gonna make these 4 and -4. So I'm gonna multiply the top by -2. So that would become -4x minus 6y equals -12. The bottom one stays as is. And then what we notice is, not only are the x's gonna eliminate, but at the same time, my y's eliminate. We haven't seen one like that yet, on elimination anyway. So all we have left over here is 0. Not 0x, not 0y, just 0. There's nothing left. My x's and y's have disappeared, they're gone. Over here on the right-hand side, we have 6. So 0 is not equal to 6. So this is one where we say no solution. There is no ordered pair that makes these two equations work. If it was infinitely many solutions, I'm not going to do one of those with you, but it could still happen on elimination. We could still have infinitely many solutions. What would happen is everything would cross off. The x's are gone, the y's are gone, and these would make 0, so everything would disappear, and that means the two equations are exactly the same. So it would be infinitely many solutions. So just trying to show you the difference between those two. All right, assignment. Same page as yesterday. Just the second half of the assignment.